Hello, 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 my life. Hello, hello, hello. Is my mic working? Okay, it should be good. Let's start. First, let's solve this problem. Min Problem 3768. Minimum inversion count in subarrays of fixed length. This problem requires segmentary slash Fenwick tree concept. This was asked in recent bi-weekly contest that I was not able to solve. So let's try this problem now and see whether or not we are able to solve it. No? Uh, You are given an integer array nums of length n and an integer k. Okay. An inversion is a pair of indices I, comma, j from none such that I less than j and nums of I is greater than nums of j. The inversion count of a subarray is the number of inversions within it. The inversion count of a subarray is the number of inversions within it. Return the minimum inversion count in all subarrays of lengths with length k. Hmm. Hmm. So if we have a range, right? Hmm. How do I write this? Should I just use a pen with? I should just use a pen. With class. What do we need this? Public take. This will be int 20. This will be int update. We need the keywords and the value for query. We only need the index. So to update, right? While n result equal to 0, LDX is greater than 0, IDX is less than x, and bits dot length on certain operations. Now here the R result is equal to bits of IDX, and IDX or just ID equal is equal to all the numbers that are greater, right? If greater less, the numbers are greater. So do this. Highlight is equal to highlight and this. similar to array is equal to. First, we need the count of numbers that are greater than this number, greater than the nums I. Wait, wait, wait. I is smaller, but nums j is greater. Oh, sorry, nums I is greater. So, yes. Oops. And then here we have array and and x array is equal to less equal to 1 or value rather. Okay, now we have a basic inventory set up int int equal to, let's see the constraints. Nums of I can go up to 10 power 9, but the nums dot length can be up to 10 power 5. So this can be 1, 2, 3, plus 2, just for safety. Yes. Okay. Now we need to use coordinate compression here, right? So first let's do this new thing size and um for int I equal to 0 I less than nums dot length I plus plus let's use a hash map. This and let's call it count for compression. This is coordinate compression. New hash map become this. Okay. Oh, huh. Okay. Now, if form dot contains key, what is that key? Nums of I. If it doesn't contain the key, just add or rather put that value and then the index. Index plus plus. Um, yeah, wait a minute. Yeah. Int id equal to 0. This will be id plus plus. Then, hmm, now, wait. Now we have int size equal to id, which equal to new int of size. This is id is already incremented by 1 because of this. Now Now, what do we do? We run a for loop and type equal to 0, nums dot length, I plus plus. Let's first run it only up to k. Up to k, and then just increase it, keep increasing it by 1, decreasing it by 1. Right? Yeah. First, let's run it up to k. So, what's this? We need to only update first int c equals to um form dot get nums of I. Once we got the value c, and then this update all the numbers that are bigger than it plus 1. Yeah. Mm, okay, yeah, this makes sense. Right now, just use a sliding window where while j is um let's initialize j int j equal to k, or is k always less than equal to n? Okay. Oh, this is one based index. Whoops. This will be 1. This will be nums of I. Wait, we can make this one based index. Yeah. This will start from 1, right? So we should be good. Mhm, 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 mhm. This is this. J equals to k. J is less than dot length. Int I equal to 0. Just k minus 1 basically. At k minus 1. Now increment I, increment j. Yes, increment I, increment j. Now first, what do we do? First, we query first. One, minimum inversion point. Okay. And let's C equal to form dot get nums of I. Now, now, um, we have at this value. Query this and this. We have our right and left. But shouldn't this be L minus 1? So this minus 1, right? So we have something result equal to integer dot max value max dot min r minus L I plus plus u plus plus. Now we get this value j value and update c comma 5. At the end, just return result. Will this work? This is int only. Oof, integer. Okay, no problem. Oh my god, r minus l and result. At line 9. Oh, oh, why? Oh, this should be void and return result. Whoops. Out of bounds error. Nice. So, yeah. So we need to do this ahead of time. We have it and result equal to this. Result equal to query of no, 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 no. Query of L, no, right, minus query of L minus 1. Int R equal to nums of k minus 1. I mean, com dot get and int L equal to com dot get nums of 0. Then minus 1. Ah, this is equal to result. Then what do we do? J equal to k, this equals to 1. Now, what do we have? We have we update this value, then get C1, C2, get L1, L2, and then find this. Okay, we should be good. Sorry, get this, then subtract it by minus 1. Hopefully this doesn't give an error. System dot out dot print, and then L and R, and also the result. R minus L result equal to this. Let's see. 4 minus 1 3. Result was also 3. There were 4 numbers. 1, 2, 3. Wait, let's first check for this as well. Oh, wait. This will be -1. Yeah, yeah. Whatever. That is literally the same. Okay. Let's see. 1, 2, 3. How is there? This is R minus L. 3. How is the result equal to 1? Oh, wait. We need query of this result. Query R. Whoops. Okay. In this range, you have only one number that is. Oh, we have two numbers that are less than. Oh, wait. Nums of I to this. Oh, so we need to move from behind. Oh my god. We are at nums dot length and I is greater than nums dot length. Dude, I need to name this something. Oof. And don't need this, right? Int n equal to nums dot length. Wait a minute. I equal to n minus 1. It is greater than n minus k minus 1. Yeah. And this is I minus minus. keep updating, keep updating, keep updating, keep updating. And then when we reach up to this point, that's when boom. Int L equal to this. Let's name this C1, C2, R. Int R equal to this. Int L equal to this. R minus L equal to R minus L, and then this is the result. Now, oh, 1, 2, 3. Yeah, this is 3. In this range, number of elements greater than this. I in this range. Is the number of inversions within it. Hmm. And then here, while now, where is I? I is greater than equal to 0. I is at n minus k minus 1, and k is at j is at n minus 1. Now get this. I update. Okay, this minus 1, and j is at again minus 1. Decrement I, decrement j. Number of elements less than this, and then plus 1. Basically, we want number of elements greater than this index. Query should return number of elements greater than this index. Oh, this is a great number of elements that are less than this index. Number of elements less than this index. Number of elements less. No, no, number of elements that are less than this value at this index. The number of elements that are less than the value at this index. This index plus 1. We remove all of that. Okay. Do we do, should we do elimination? Should this be elimination? Uh, hmm, yeah, it's just this. Oh, numbers of, why is this numbers of 0? Wait. This will be n minus 1, n minus 1 minus k, and this will be plus 1. Yeah. Mhm. Okay. This one and this 4. This one. This. How is it called any compression wrong? Should this be R minus L or something? Oh, yeah. We need to sort this. Very range. Very R minus. Very L minus R. Yeah. I should have taken this. um public int query range int L int R return query R minus query L minus R. Yeah, yeah. We need to sort this array first. I forgot something. Int sorted equal to nums dot loan. Then we check in the sorted array. This will be sorted. Maximum rank plus one. Yes, yes. Initialize this. Perfect. Inversion sliding window. R is equals to rank dot get this. Hmm. Oh, okay. Maximum rank best makes sense. Hmm. These are the number of versions. Oh, it can be long. Hmm. Answer equal to long max value. What is the rank for this compression? Compression dot get nums of I. So this is not even required. This is not going to be for impact because required is less than n I plus I in C equal to com dot get nums of I. We start from one. Yes, we do. Now, what does this mean? We have our compressed value here, number of elements greater, nums of I, no, Okay. Now what if I is greater than equal to k, int outrank rank dot get numbers of I minus k, inversion minus equal to query range of outrank plus 1 till r, and then update outrank with minus 1. If I is greater than equal to k minus 1, answer equal to this. Wait, I need to watch that YouTube video. Dude, my short is not progress.
The update part. This is the update part. Now there would be a query part, right? There would be your
Imagine.
and plus one if you add the numbers. Your original array, right? But what I will be doing, first I will so because victory. So here what I'll be doing, let's assume
J is greater. Okay. This is a bit complicated. Let me do it my way. Int I equal to n minus 1. I greater than equal to n minus 1 minus k. I minus minus. We calculate all the inversions in this range. Calculate all the inversions in this range. So inversion plus equal to vary left to right. Now, from this index, that is int c equal to com dot get nums of I. From this to the end, till the end. Yeah, count all the inversions. The inversion count of a subarray and minimum inversion count among all subarrays. Okay, after counting all the inversions, just check once math.min answer and inversions. Now we use a sliding window technique. Now for int I equal to n minus, wait, is this the n minus 1 minus k and I is greater than equal to 0, I minus minus. What do we want? We want the inversion of, get the inversion, first get the compressed value of nums of I. Now get the inversion vary from this index till the end, till the end. Then subtract query from I plus k. So this is I plus k until n. This is how you use the inversion, oh sorry, the sliding window technique. Now, what you do is update C with 1. Should we just here update n minus 1 to minus 1. So from that index to every other index, it will be 0. Minus 1, right? So update C Now, this cannot be n minus 1. Into com dot get nums of n minus 1. This val query from this, update this, and then update val equal to com dot get nums of n minus 1 plus k. Now update this val with minus 1. Now check answer equal to math dot min of answer and inversion. Then which is taken also. This should be query range. This will be I plus k. Right. Yeah.
Let's assume this is your k size subarray, right? And I want to slide it. So I'll be using some sliding window kind of mechanism, right? For each k window, k window subarray, right? I'll be kind of sliding it right side by one. So if you so let's say for this k size subarray, the size of this subarray is k. The size of this subarray is k. Let's say for this k size subarray, I have already calculated the inversion value, right? Let's say that inversion is something inversion, right? I already have inversion calculated for this k size subarray. Now let's say I slide this subarray. This matters is what are the values of these two numbers, right? So this included number, excluded number, right? So we know that for this subarray, right, for this subarray of size k, the inversion using this was contributed in this inv, right? This in this inversion value. And what would be those inversion? That inversion would be what are the numbers, I mean the count of number in from the next range whose value is less than that x, right? Because we know that for the inversion these two conditions should be satisfied. The first condition is already satisfied, like the index of that number is anyway less than all these numbers, and the value should be more than these numbers, right? So just check how many numbers are there whose value is less than this number of plain. To include this number for that. So yeah, I hope you understand. There would be a query. The total is, and plus one if you add the number. So this value is less than x in the current window, right?
For the query, you subtract okay. Oof.
This is my size first originally nums, then I have make it unique like combo. I have its index, and this will give you a normalized array like 2 4 3 for the first k size sub array, right? So we cannot slide the window, we have to calculate um, the inversion of the first k size sub array. So for that, so this query would, so we know that since here you have to add the number, right, because like there is no exclusion, because this the size of the array is even less than k. So we know that this query will give you the smaller number, but once you add the number you have to find out those number whose value is more than me, right, whose value is more than me. So what I have done, so among all these ith number, just subtract how many number among me, right, whose value is more than. Once you add the number you have to find out those number whose value is more than me, right, whose value is more than me. So what I, we know that the size of the array is even less than k. So we know that this query will give you the smaller number, but once you add the number you have to find out those number whose value is more than me, right, whose value is more than me. So what I have done, so among all these ith number, just subtract how many numbers are smaller than me. So these numbers would be greater than me, and that essentially your inversion smaller than me. So all these ith number, just subtract how many numbers are small.
How many numbers are smaller than me?
Smaller than me.
Okay. And then update this. So inversion will be equal to I minus query of com dot get nums of I. So this, and then update C with 1. Okay, this makes sense because this will get us the inversion. What does update do? This get increment all the numbers that are greater than this number, add it or make it plus 1.
So these numbers would be greater than me, and that essentially your inversion. So just increment your inversion. This current is essentially your inversion, and now update value. So since now you want to add this number, right? So to add, we would be contributing at +1. Now the inversion value. This is your answer. Now for index k to n, what we'll be doing, we will slide this window by 1, right? So
Date I minus k2. Yeah. Why did you do a -1 here?
this ith number would be added, and I minus kth number would be subtracted, right? Removed. So just remove it, and just subtract your inversion value. Now now your current ith number would be added, right? So now you have to include this ith number. So to calculate the inversion value, first find out the smaller number and subtract it from the size k
Hmm.
k I mean, so this is the formula. Just subtract it from the total size. This will give you the contribution of inversion for the ith number.
Why is it k minus 1 then?
And just update your I mean, just add this number. So to add, we would be contributing at +1.
Yeah. K minus 1 minus the query Hmm. How would you convert this? It's okay. Good. I get it sorted. Slide the window. Remove leftmost element. Convert nums of I minus k. The leftmost element. We are trying to get this position for int I equal to k, I less than n I plus plus. Remove int left equal to forms dot get nums of I minus k, get the leftmost element and remove that. So update left to minus one. You don't have this no more. And get this element. Get add the rightmost element. Current. Now this is inversion minus equal to query of left left minus one. Why did we do a minus one here? Why did we do left minus one? Because we are literally here. Very variables number of active elements strictly smaller than x. Mm, Typically smaller than X. Ah, okay, 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 okay. Yeah, 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 yeah. Then after that, int c equal to com dot get this current element, and then inversion is equal to query of this element. Get all the numbers smaller than this element. But first, query of n. Why will be subtracted from query of n? Why did subtract from query of n? All the elements query of n. From the last index. But wait, n, do we know what n is? Yeah, this is n. N is compressed ID. So this is basically um query of size from the last index. All the numbers that are smaller than that minus all the numbers smaller than this, all the numbers smaller than this. So we get all the numbers greater. Get all the numbers greater than this current index. Hmm. And we add that. Yeah, that is the inversion. Yeah, 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 yeah. We check for the behind the numbers that are behind. This contributes to our inversion. Update this with 1. Then answer equal to math dot min of answer and inversion. At the end we return our answer. ID is y is equal to this is ID minus 1 actually, so size plus 1. And then here we do size. Yeah. Did I print statement? No. Okay. Oof. Okay. Okay. Let's solve today's daily problem. Problem 3606, coupon core validator. You're given three arrays of length n that describe the properties of n coupons. Core business line and is active. The ith coupon has code I, a string representing the coupon identifier, business line, a string denoting the business category of the coupon, is active, a boolean indicating whether the coupon is currently active. A coupon is considered valid if all of the following conditions hold, that is, code I is non-empty and consists of alphanumeric characters and underscores. Um, and a business I is one of the following four categories. This and is active is true. Okay, we're doing three arrows. Code business line. Return an array of the codes. Okay, of all four. Return an valid coupon sorted first by their business line in the order electronics, grocery, pharmacy, restaurant, and then by code in lexicographically assigning array. This is a stupid problem. Very stupid problem. 1, 2, 1, 2. Just problem. This is the problem. Okay, I'm not spending my time solving this. This is a very stupid problem, not worth the time. And we gonna see business line and then the code. Now sort this based on the priority of zero must be of zero. If is not equal to zero, return yes. Return A1 number compared to equal B1. Okay, question, yeah, this is my preference. Yeah, this is this. A2 is 8, it is 0 to 9, and then just goes what plus this. mm, the string dot matches prefix. The entire string matches the red box. Okay, define the character and just one more of those characters. Okay, nice. Yesterday also we had a very stupid problem based on sorting or something. So, yes, what wait, did it change the actual file name or something? Valid coupons. Valid coupons. So what is it? Oh, valid date coupons. Yeah. Okay. Hmm. So let's learn about AI. I'm just trying to search some YouTube channel. Oh, wait, before that, let's watch Larry's video on this.
This is Larry. This is me in Ascension here in Paraguay. Yeah, I'm on a mountaintop. I'll show you some drone views. Let's go. Everybody, this is Larry. This is day 13 for the Legal Day Challenge. The like button, hit subscribe button, join me in Discord. Let me know what you think about today's problem. Today will be easy, yes. And as you may tell, because I told you in the intro, I am here in Paraguay, in Ascension. Ascension. Hopefully I'm saying that right. Let me know in the comments. Yeah, no penguins for today because we did other stuff, but penguins will be back because I have so many videos to look for. Yeah, they'll be good. Anyway, let's take a look at today's problem. We have 3606. I almost forgot. I was like, okay, good night, everybody. But yeah, 3606 coupon code validator. Given 3 ways of length n, describing n, the properties of n coupons, code, business lines, and is active. The IF coupon has these 3 things. A coupon is considered valid if, maybe I should, okay, the identifier, the category, and whether it's active. Fair enough. Code has some rows, business line has 4 things, and it's active is, this is if it's valid if all these holds. So we have to validate on code, validate on this, and that it is true. We turn an array of all valid coupons, and then you have to sort them and then code it in lexicographical order within each category. EGPR is the right order, right? So we don't have to like do a mapping. And then lexicographically order. Oh, the code. We sort the code. Okay. I mean, of course, let's just do it one. You know, I think one thing that you can do, and maybe it's not a great habit, is that you can try to do everything at once. But a better habit is just break it down into components that you can think about. Maybe even have a helper function. Though for LeetCode, maybe that's a little bit of overkill. Just breaking down the components that you can do individually, right? Sorry if my eyes are kind of weird and I'm like looking like, you know, I mean, this is an easy problem, so that's good. But yesterday I had 2 hours of sleep. I don't know about, I don't remember. No. I talked about it in my ad random code. Stepping up. My apologies. Faster. Right. Um, good code or good coupons maybe. Right, and then now we just put in good coupons. We want to put in the business line, right? And we also want to put in this is not
Code.
supply is B and A, right?
C,
And then
right?
now we do another sort later, but let's do this part first.
It should be C, not A.
See, but I would consider that a premature optimization. So really think about your and of course you can also use a enum here if you want to really think about efficiency. But I would consider that a premature optimization. So let's not worry about it for now. So okay, so code is good if it is non-empty and only has these things, right? So for C and I wonder if there's like a thing, but a lot of weird. I one first turn. Okay, hopefully better. There's an empty string. Why do I have an empty string? Dong dong dong. Oh, empty string is a valid code. It's non-empty, which that means my good function is poor. So yeah, if length of code is equal to 0. I mean, this is literally like spelled out for you, but you know, I am not a smart boy. But because I kind of just, you know, it looks good. That's why I have this one. Let me know what you think. Thanks.
Okay. Oh, great. S- 104 videos. Neural networks, deep learning. Wait, what was my problem statement? What was my problem statement? Well, Okay, so this was my problem statement, right? Yeah, this and the constraints. What are the requirements for this problem statement? Okay. Role-based access control. Build a fully offline privacy preserving track-based knowledge portal that ingests local documents, indexes them with embeddings, and allows users to query them via citation back chatbot. What should what are what should I learn to be able to complete this project? I am beginner, suggest give me a proper roadmap so that I am able to complete this project and learn all the things required.
Gonna start this stat quest with a silly song. But if you don't like silly songs, that's okay. Stat Quest. Hello, I'm Josh Starmer and welcome to Stat Quest. Today we're going to do a gentle introduction to machine learning. Note, this Stat Quest was originally prepared for and presented at the Society for Scientific Advancement's annual conference. One of the things that SOSA does is promote science and technology in Jamaica. Let's start with a silly example. Do you like silly songs? If you like silly songs, are you interested in machine learning? If you like silly songs and machine learning, then you'll love StatQuest. If you like silly songs but not machine learning, are you interested in statistics? If you like silly songs and statistics but not machine learning, then you'll still love StatQuest. Otherwise, you might not like StatQuest. Wah wah. If you don't like silly songs, are you interested in machine learning? If you don't like silly songs, but you like machine learning, then you'll love StatQuest. If you don't like silly songs or machine learning, are you interested in statistics? If you don't like silly songs or machine learning, otherwise, you might not like StatQuest. Wah wah. This is a silly example, but it illustrates a decision tree, a simple machine learning method. The purpose of this particular decision tree is to predict whether or not someone will love StatQuest.
Just a minute. Wait. Why is my laptop lagging so much? Activity monitor. Okay. CPU load. Why is it so high? Memory is still fine. Wait. Yes. Okay, it's back to normal, I guess. Okay. I don't need prior ML experience. Beginner project ready roadmap offline gap 10 to 14 weeks. Assumes basic computer usage, no AI background. Foundation, very important. Python basics. Okay. Write a Python script that reads a text file, processes line, saves output to another file. Python for everybody. Okay. Get and project structure. I know all of this. Core AI concepts, no math heavy. NLP basics. Don't forget to learn concepts. What is RAG? History of course real feature. Chunking text. Mm. I want to learn about NLP first, then if I don't need machine learning, I believe what is it called? NLP basics. So should I just search what is NLP instead? My hair is messed up. And my shirt is not pressed as well. Distance. What is NLP?
What is natural language processing? Well, you're doing it right now. You're listening to the words and the sentences that I'm forming, and you are forming some sort of comprehension from it. And when we ask a computer to do that, that is NLP, or natural language processing. My name is Martin Keane. I'm a master inventor at IBM, and I've utilized NLP in a good number of my invention disclosures. NLP really has a really high utility value in all sorts of AI applications. Now, NLP starts with something called unstructured text. What is that? Well, that's just what you and I say. That's how we speak. So, for example, some unstructured text is add eggs and milk to my shopping list. Now, you and I understand exactly what that means, but it is unstructured, at least to a computer. So what we need to do is to have a structured representation of that same information that a computer can process. Now that might look something a bit more like this, where we have a shopping list element, and then it has sub-elements within it, like an item for eggs, and an item for milk. That is an example of something that is structured. Now, the job of natural language processing is to translate between these two things. So NLP sits right in the middle here, translating between unstructured and structured data. And when we go from unstructured here to structured this way, that's called NLU, or natural language understanding. And when we go this way from structured to unstructured, that's called natural language generation, or NLG. Well, we're going to focus today primarily on going from unstructured to structured in natural language processing. Now, let's think of some use cases where NLP might be quite handy. First of all, with language processing, or N understanding, and when we go this way from structured to unstructured, that's called NLU, or natural language understanding, and when we go this way from structured to unstructured, that's called natural language generation. Translation. Now, when we translate from one language to another, we need to understand the context of that sentence. It's not just a case of taking each individual word from, say, English and then translating it into another language. We need to understand the overall structure and context of what's being said. And my favorite example of this going horribly wrong is if you take the phrase, the spirit is willing, but the flesh is weak, and you translate that from English to Russian, and then you translate that Russian translation back into English, you're going to go from the spirit is willing, but the flesh is weak, to something a bit more like the vodka is good, but the meat is rotten, which is really not the intended context of that sentence whatsoever. So NLP can help with situations like that. Now, the second kind of use case I like to mention relates to virtual assistants and also to things like chatbots. Now, a virtual assistant, that's something like Siri or Alexa on your phone that is taking human utterances and deriving a command to execute based upon that. And a chatbot is something similar except in written language, and that's taking written language and then using it to traverse a decision tree in order to take an action. NLP is very helpful there. Another use case is for sentiment analysis. Now, this is taking some text, perhaps an email message or a product review, and trying to derive the sentiment that's expressed within it. So, for example, is this product review a positive sentiment or a negative sentiment? Is it written as a serious statement or is it being sarcastic? We can use NLP to tell us. And then finally, another good example is spam detection. So this is a case of looking at a given email message and trying to derive, is this a real email message or is it spam? And we can look for pointers within the content of the message. So things like overused words or poor grammar or an inappropriate claim of urgency can all indicate that this is actually perhaps spam. So those are some of the things that NLP can provide, but how does it work? Well, the thing with NLP is it's not like one algorithm. It's actually more like a bag of tools, and you can apply these bag of tools to be able to resolve some of these use cases. Now, the input to NLP is some unstructured text, so either some written text or spoken text that has been converted to written text through a speech-to-text algorithm. Once we've got that, the first stage of NLP is called tokenization. This is about taking a string and breaking it down into chunks. So if we consider the unstructured text we've got here, add eggs and milk to my shopping list, that's 8 words, that could be 8 tokens. And from here on in, we are going to work one token at a time as we traverse through this. Now, the first stage, once we've got things down into tokens that we can perform, is called stemming. And this is all about deriving the word stem for a given token. So for example, running, runs, and ran, the word stem for all 3 of those is run. We're just kind of removing the prefix and the suffixes and normalizing the tense, and we're getting to the word stem. But stemming doesn't work well for every token. For example, universal and university, well, they don't really stem down to universe. For situations like that, there is another tool that we have available, and that is called lemmatization. And lemmatization takes a given token and learns its meaning through a dictionary definition, and from there it can derive its root or its lem. So take better, for example. Better is derived from good, so the root or the lem of better is good. The stem of better would be bet. So you can see that it is significant whether we use stemming or we use lemmatization for a given token. Now, next thing we can do is we can do a process called part of speech tagging. And what this is doing is, for a given token, it's looking where that token is used within the context of a sentence. So take the word make, for example. If I say, I'm going to make dinner, make is a verb. But if I ask you what make is your laptop, well, make is now a noun. So where that token is used in a sentence matters. Part of speech tagging can help us derive that context. And then finally, another stage is named entity recognition. And what this is asking is, for a given token, is there an entity associated with it? So, for example, a token of Arizona has an entity of a US state, whereas a token of Ralph has an entity of a person's name. And these are some of the tools that we can apply in this big bag of tools that we have for NLP in order to get from this unstructured human speech through to something structured that a computer can understand. And once we've done that, then we can apply that structured data to all sorts of AI applications. Now, there's obviously a lot more to it than this, and I've included some links in the description if you'd like to know more. But hopefully this made some sense and that you were able to process some of the natural language that I've shared today. Thanks for watching.
Stop buying those.
Hello everyone, welcome to this NLP crash course. In 1 hour, we will move from I've heard about NLP to I understand how it works and can start building simple NLP models. Let's start with a quick question. Have you ever chatted with a customer service robot, asked Alexa to play your favorite song, or used Google Translate? If so, then congratulations. You've already employed NLP, or natural language processing. Let me show you some examples in action. Example 1, chatbot response. When you enter a chatbot and ask, what's the weather like today? It reads your sentence, extracts information, and responds, all via NLP. Example 2, sentiment analysis. Companies track thousands of tweets daily to determine whether people are happy, angry, or confused about their products. Cons, all via and ask, what's the weather like? Example 1, chatbot response. When you enter a chatbot and ask, what's the weather like today? It reads your sentence, extracts information, and responds, all via NLP. Example 2, sentiment analysis. Companies track thousands of tweets daily to determine whether people are happy, angry, or confused about their products. That's NLP filtering and classifying words. Example 3, Google Translate. You type good morning in English, and voila, it shows up as buenos dias in Spanish. What happens behind the scenes? NLP and machine translation models. So, what are we going to do in this crash course? Here's the goal. By the time this video is complete, you'll understand how NLP is done, the key concepts involved, and how you can start building your own NLP models, even if you're new to the topic. We'll break it down into clear, bite-sized chunks, starting with what NLP is and why it's tricky, then moving into the NLP workflow, the foundations like tokenization and text representation, common NLP tasks, and finally, some advanced topics and modern tools like transformers and Hugging Face. Think of this as a guided tour of the NLP world, with theory, mini demos, and practical tips along the way. And here's the exciting part. This isn't going to be an abstract lecture. You'll see actual code snippets and real examples that make the concept stick. So whether you're a data science student, a developer curious about AI, or just someone who loves understanding how machines understand language, you're in the right place. Let's get started. Now that you've seen a few examples of NLP in action, let's unpack what it is and, more importantly, why it's such a challenging field. What is NLP? Natural language processing, or NLP, is an area of artificial intelligence focused on getting computers to process human language. Not just shallow word matching, but meaning, context, and intent. The natural in NLP refers to human languages, like English, Hindi, Spanish, or Mandarin, as opposed to artificial languages, like programming languages. At its core, NLP is about bridging the vast gulf between human communication and machine thinking. While human beings speak in sentences, stories, and emotions, machines communicate using numbers and rules. NLP acts as the interpreter between these two spaces, taking natural language and converting it into something that a machine can compute, and vice versa. Wondering where NLP is used? You might not even realize it, but NLP powers a lot of technology we all use daily. Search engines such as Google employ NLP to interpret your query and return the most precise results. Voice assistants such as Alexa, Siri, or Google Assistant translate your spoken commands and carry them out. Language translation software uses NLP to translate text from one language to another without losing meaning. Spam filters for email use content and tone to detect unwanted email.
3 things which can completely transform your life. Number 1.
Summarization algorithms condense lengthy news articles into concise summaries. Social networks use sentiment analysis to monitor public opinion through posts and comments. So, why is NLP so difficult? You might wonder, if humans acquire language innately, why can't computers? It's quite simply the unbelievable richness and subtlety of human language. It's not just a question of words. It's a question of meaning, feeling, and context that constantly changes. Ambiguity. Most words carry more than one meaning. Consider the word bank. For instance, it can mean a financial institution, the riverbank, or a bank of switches. While human beings tackle such ambiguities easily with the help of context, machines have to be specially trained to do so. Slang and informal language. Language evolves all the time. Slang words such as "that's lit" or "this movie slaps" can confuse older models. Catching colloquial language, memes, or internet slang requires constant tuning, context, and multiple senses. The phrase, "I saw her duck," has 2 wildly different interpretations. Either the bird or quick physical action. Good interpretation boils down to extremely subtle contextual clues. Sarcasm and tone. Machines often struggle with tone. "Oh great, another meeting," might be taken positively, but it's actually sarcastic. Sarcasm detection requires more than literal meaning. Structural differences between languages. There are differences in grammatical structures between languages. English's subject-verb-object-word order, I eat apples, differs from Japanese subject-object-verb, I apples eat. Translation models must contend with these deep semantic differences. Data quality and variations. Real-world text is messy. It has spelling errors, typos, code switching, use of multiple languages, and variation in writing styles, all of which make consistent understanding a challenge for computers. To gain a better understanding of modern NLP, it's helpful to look at how NLP has evolved over the decades. Era 1.
Wait, I will be back. I need to eat some food first. And then I will be back soon. I'll be back soon. Good luck. Okay.
Rule-based systems, 1950s to 1980s. In the early stages, NLP systems were designed using hand-coded rules. A classic example of this is Eliza, 1960s. A simple chatbot that mimicked a psychotherapist by echoing user input in the form of questions. These systems were easy to manipulate and deterministic, but rigid. They collapsed completely when the input deviated from pre-coded rules. Era 2. Statistical methods. 1990s to 2010s. The introduction of the internet produced a deluge of text data. Researchers began using statistical techniques to learn from data rather than designing specific rules. Models like naive Bayes, logistic regression, and hidden Markov models enabled machines to predict by identifying patterns. These were more flexible, but still struggled to understand long-term context or deeper meaning. Era 3. Neural networks and transformers, 2015 to present. Deep learning revolutionized NLP. RNNs, recurrent neural networks, and LSTMs, long short-term memory networks, improved word sequence comprehension. Later came the advent of the transformer architecture, used in BERT, GPT, and T5 models. That rocketed NLP to unprecedented heights. These models process whole sentences in parallel, learning complex contextual relationships. As a result, today's NLP systems can generate essays, translate languages, summarize text, and more, often with near-human fluency. Why this is important to you, as often with near-human fluency. Complex contextual relationships. As a result, today's NLP systems can generate essays, translate languages, summarize text, and more, often with near-human fluency. Why this is important to you as a student. Understanding the issues NLP faces helps you appreciate the design decisions that go into the methods and tools you'll study in this course. Each pre-processing step, model architecture, and pipeline component exists to overcome one or more of the aforementioned challenges. So, as you delve deeper into NLP, keep these challenges in mind. Ambiguity, changeable or casual language, context and polysemy, sarcasm and tone identification, cross-linguistic differences in structure, and dirty real-world data. Next, we'll guide you through the NLP workflow, a process of steps that transform raw text into something machine actionable. The foundation you'll gain will leave you ready to build solid NLP applications yourself. Having covered what NLP is and why it's hard, let's examine how NLP projects actually get built. If you took a tour of any NLP team at a tech company, you'd find that whether they're building a chatbot, translation system, or sentiment analysis tool, they're going through a fairly standard process. You can think of this workflow as an assembly line for language.
This was
Raw text goes in at one end, and an intelligent, task-ready model comes out the other. The exact details vary by project, but the core pipeline usually includes these stages: data collection, pre-processing, feature extraction, representation, model training, evaluation, and deployment. Let's walk through each stage. To make it real, we'll use an example project: spam detection for emails. Starting with data collection. Everything starts with data. Without it, there's nothing for a model to learn from. For spam detection, you'd gather a dataset of emails labeled as either spam or not spam. Sources might include open datasets, like the Enron email dataset or the Spam Assassin dataset, or internal company data, if available and privacy compliant. Here's the catch. Your model is only going to be as good as your data. If your dataset doesn't contain characteristic spam patterns like win a free iPhone or click here for a special offer, then your model will miss them in the wild. In NLP, more data is better, but representativeness and diversity are just as crucial as size. Moving on to the pre-processing part. Once you have raw text, you can't simply hand it off to a model. Text needs to be cleaned up and standardized so it's easier for machine to deal with. For our example of spam detection, pre-processing might include tokenization, dividing text into words or subwords, i.e. free iPhone today equals free iPhone today. Lowercasing, converting all text to lowercase, so free and free are equivalent. Removing stopwords, tokens like the, is, at, that don't add much meaning in most tasks. Stemming and lemmatization, reducing words to their base forms. Example being running to run. Removing punctuation, numbers, or special characters, task dependent. For spam filtering, this pre-processing step guarantees that free and free are functionally the same signal. Moving forward to feature extraction and representation. Here's the fact. Computers don't really know text. They work with numbers. So the next step is to turn your cleaned words into a numeric representation. Standard techniques include bag of words, BOW, a simple count of how many times each word occurs. TF, IDF, term frequency, inverse document frequency. Scale counts by how often words appear across all documents. This assigns greater importance to unique words like lottery and less common words like the. Word embeddings like word to vec, GloV, represent words in dense vectors that capture semantic relationships. An example being king, man, plus woman, queen. For spam filtering, a BOW or TF-IDF matrix can be sufficient to mark suspicious words like winner, prize, or urgent. Let's proceed to the major component, model training. Now that the text is numerical, we can train a model to identify patterns. For spam filtering, common algorithms are naive Bayes due to its simplicity, speed, and surprising effectiveness. It remains a popular choice for text classification. Logistic regression, a good starting point for binary classification tasks. Random forests or gradient boosted trees, good for structured features. Deep learning models like transformers, LSTMs, excessive machinery for basic spam filtering, but suitable for complex NLP applications. During training, the model will learn to identify which patterns in the features correspond to spam or non-spam labels. Now, let's measure the quality of the model via evaluation. You can't just rely on a model because it works on training data. You must test it on data it hasn't seen yet. For spam filtering, you might use metrics like accuracy, ratio of correct predictions. Precision, out of all emails that we labeled as spam, what percentage were actually spam? Recall, out of all actual spam emails, what percentage did we capture? F1 score, the harmonic mean between precision and recall. If your precision is poor, you're incorrectly flagging legitimate emails as spam, and this irks users. Once you're satisfied with the model's performance, integrate it into your email system so it can start working in real time. When a new email arrives, the model automatically pre-processes the text, extracts relevant features, and classifies it as either spam. Visualize the workflow. Consider the spam detection pipeline as a step-by-step process. It lowers complexity. Insufficient challenges we've been discussing can represent text. We'll also have little code examples so that you can see these steps happen, not just hear about them. Up to this point, we've just glanced at the general NLP process. Let's now spend the next few minutes delving into its foundation, the fundamental building blocks that power and prepare raw text so it's ready for models. Smaller units, tokens, that may be words, subwords, or characters. Models cannot handle entire sentence as a single string, so breaking it up into tokens gives them manageable bits to work with. Some newer models, like BERT, use subword tokenization to handle unknown words. The provided example code tokenizes a sentence into words with Python's NLTK library and returns them as a list. Lowercasing is another important process that ensures consistency. Without this, dog with capital D and dog with lowercase d would be treated as two distinct tokens. The shared sample code lowers all the tokens in a list to provide consistency. We often also perform stop word removal, eliminating common words like the or is, which typically have little meaning for many tasks, such as classification. For others, such as machine translation, though, removing them would be counterproductive to meaning. The provided example code uses NLTK's built-in list of stop words to eliminate common words from the token list. And then there are stemming and lemmatization, both of which reduce words to their stems. Stemming uses simple algorithms to strip off word endings. Quick, but sometimes imperfect. Lemmatization uses vocabulary and grammar rules to find the true root form. Stemming is fine when speed is of the essence, while lemmatization is better when meaning matters.
We didn't make way.
The provided example code demonstrates stemming and lemmatization using NLTK, contrasting the reduction performed by each method. Based on the application, pre-processing can also include stripping punctuation, ignoring numbers if irrelevant, spell checking, or handling emojis, all of which can be required for sentiment analysis. After the text is cleaned, the second hurdle is that computers cannot read text directly. They can read only numbers. Therefore, we must convert tokens to numbers while holding meaning constant. That is called feature extraction or vectorization. The simplest method is known as bag of words, BOW, which represents a document as the frequency count of words. Basic, but effective for some classification tasks. It doesn't capture word order and results in sparse, high-dimensional vectors. The provided example code uses scikit-learn's count vectorizer to produce word frequency counts per document in a corpus. An extension of this is TF-IDF, term frequency inverse document frequency, where rare, information-rich words get higher weights and common, less informative words are downweighted. This is helpful in tasks like spam filtering, where some extremely rare words are extremely good predictors.
हेलो फ्रेंड्स, वेलकम टू ग्रेट स्मैशर। आज की इस वीडियो में हम डिस्कस करने जा रहे हैं नेचुरल लैंग्वेज प्रोसेसिंग। तो एनएलपी आर्टिफिशियल इंटेलिजेंस का वन ऑफ द मोस्ट इंपॉर्टेंट और लेटेस्ट टॉपिक है। तो इस वीडियो में हम एनएलपी के बारे में पूरी डिटेल में डिस्कस करेंगे विद लाइव एग्जांपल्स, और ये वीडियो आपको बहुत ज्यादा हेल्प करेगी, स्पेशली कॉम्पिटिटिव एग्जाम्स में, या फिर आप अपने कॉलेज या यूनिवर्सिटी लेवल के एग्जाम की प्रिपरेशन कर रहे हो, या इवन इंटरव्यूज की प्रिपरेशन कर रहे हो। तो एनएलपी के बारे में यहाँ पे बहुत ही अच्छे फैक्ट्स जो है वो मैं शेयर करने जा रहा हूं। तो सबसे पहले स्टार्ट करते हैं। एनएलपी होता क्या है? व्हाट इज द डेफिनेशन ऑफ एनएलपी? हाउ ह्यूमन कम्युनिकेट विद ईच अदर। ह्यूमन बीइंग कैसे कम्युनिकेट करते हैं? कैसे कम्युनिकेट करते हैं? दे यूज द नेचुरल लैंग्वेज। जैसे कि मैं आप यहां पे आपके साथ कम्युनिकेट कर रहा हूं, और मैं कौन सी लैंग्वेज का यूज कर रहा हूं, मैं इंग्लिश का यूज कर रहा हूं, मैं हिंदी का यूज कर रहा हूं, हो सकता है मैं बीच बीच में पंजाबी के वर्ड्स का भी यूज कर रहा हूं। तो यहां पे मैं 2-3 लैंग्वेजेस का मिक्सचर यूज कर रहा हूं और आप क्या कर रहे हो, आप उस सारे वर्ड्स को, उन सारे सेंटेंसेस को सबसे पहले इंटरप्रेट कर रहे हो, सुन रहे हो, इंटरप्रेट कर रहे हो, अंडरस्टैंड कर रहे हो और अंडरस्टैंड करने के बाद आप रिप्लाई करते हो। तो वो क्या है, एक फुल वे कम्युनिकेशन है। तो ये कम्युनिकेशन तभी पॉसिबल है अगर आप मेरी लैंग्वेज को अंडरस्टैंड करके और अपना रिप्लाई जो है वो मुझे भेज रहे हो और वो रिप्लाई भी मैं समझ पा रहा हूं। तो ये एक्चुअल में क्या है, ह्यूमन बिहेवियर को ये क्या बनाता है, बहुत ही इंटेलिजेंट बनाता है कि हम कैसे नेचुरल लैंग्वेजेस के थ्रू कम्युनिकेट करते हैं। और यही सेम चीज कंप्यूटर शुड रेप्लिकेट द सेम थिंग। मतलब हम यही चीज चाहते हैं कि कंप्यूटर जो है ये सेम चीज को रेप्लिकेट करे, मतलब सेम चीज को कॉपी कर ले और आपस में अगर दो कंप्यूटर्स ने बात करनी है वो इस तरीके से बात करें जैसे ह्यूमन बीइंग बात करते हैं। आपस में हो सकता है मशीन और ह्यूमन बीइंग इस तरीके से बात करें जैसे कि दो ह्यूमन बीइंग आपस में बात करते हैं। तो यहां पे हम यही सेम चीज को इंप्लीमेंट करना चाहते हैं विद एनएलपी, दैट इज कॉल्ड नेचुरल लैंग्वेज प्रोसेसिंग। तो यहां पे सबसे पहले मैं बताने जा रहा हूं एप्लीकेशंस। व्हाट आर द एप्लीकेशंस ऑफ एनएलपी? तो सबसे पहले स्पीच रिकॉग्नाइजेशन सबसे ज्यादा वाइडली यूज होता है और सबसे ज्यादा रिसर्च वर्क जो है इस टाइम पे जितने भी मेजर कंपनीज है, मेजर आईटी जेंट्स हैं, चाहे वो गूगल हो, अमेजन हो, ये सारे लोग एक्चुअल में क्या कर रहे हैं, इसी के ऊपर काम कर रहे हैं। स्पीच रिकॉग्नाइजेशन में सबसे बड़ा एग्जांपल है आपका गूगल असिस्टेंट और आपने सीरी भी सुना होगा, दैट इज द प्रोडक्ट ऑफ एप्पल। तो यहां पे गूगल असिस्टेंट और सीरी में आप करते क्या हो, आप वहां पे एक क्वेश्चन पूछते हो, मतलब आप अपनी स्पीच, मतलब आप इंग्लिश लैंग्वेज का यूज करके या हिंदी लैंग्वेज का यूज करके, अभी वो सारी लैंग्वेजेस के ऊपर काम नहीं कर रहा, लेकिन अगर आप इंग्लिश लैंग्वेज में कोई क्वेश्चन पूछ रहे हो तो आप अपना एक स्पीच जो है उसको दे रहे हो, तो उस स्पीच को वो इंटरप्रेट करके, अंडरस्टैंड करके आपको एक प्रॉपर, एक वैलिड रिप्लाई कर रहा है, दैट इज कॉल्ड द स्पीच रिकॉग्नाइजेशन।
Want to master generative AI for
सेंटीमेंट एनालिसिस, ये काम भी बहुत ज्यादा हो रहा है आज के टाइम पे, स्पेशली अगर हम सोशल मीडिया की बात करें तो फेसबुक है, ट्विटर है, जितने भी ट्वीट्स कर रहे हैं इन सारे ट्वीट्स को आप क्या कर सकते हो, एनालाइज कर सकते हो। सेंटीमेंट्स का मतलब क्या है कि क्या वो ट्वीट्स जो है वो अच्छे हैं, बुरे हैं, मतलब जैसे मूवीज की रिगार्डिंग रेटिंग्स आ रही हैं तो क्या ये मूवी अच्छी है, बैड है, इसको आप ट्विटर के थ्रू भी एनालाइज करके चेक कर सकते हो। इलेक्शन का टाइम है तो इलेक्शन में किसी भी पर्टिकुलर किसी भी लीडर की आप ट्वीट्स को उठा के और उसको एनालाइज कर सकते हो कि ये मेजर फोकस किसके ऊपर किया हुआ है। जैसे कि मैंने थोड़ी दिन पहले एग्जांपल इसका किया था बाय यूजिंग द पाइथन एंड टेंसरफ्लो, इसको मैंने यूज करके आर प्रोग्रामिंग के अंदर मैंने इसको पूरा एनालाइज किया था कि कैसे हम ट्वीट्स को उठा के एनालाइज कर सकते हैं और उसका एक वर्ड क्लाउड बना सकते हैं जिसके थ्रू हमें पता लग जाएगा कि कौन सा लीडर सबसे ज्यादा फोकस जो है वो अपने ट्वीट में किसके ऊपर कर रहा है। तो यहां पे आप सेंटीमेंट एनालिसिस है। मशीन ट्रांसलेशन, मशीन ट्रांसलेशन का एग्जांपल है सिंपल गूगल ट्रांसलेट, जिसमें हम करते क्या है कि कोई भी लैंग्वेज, जैसे अगर मेरे को कोई पर्टिकुलर लैंग्वेज नहीं आती, चाइनीज नहीं आती, और ये स्पेशली मैं यूज करता हूं अपने कमेंट्स के लिए भी। मेरे पास बहुत सारे कमेंट्स आते हैं जिसमें मतलब ऑब्वियसली हिंदी और इंग्लिश, मेरे को 2-3 लैंग्वेजेस आती हैं, लेकिन कई बार उसमें बंगला का लिखा होता है या उसमें कई बार तमिल की लैंग्वेज का भी यूज किया होता है। तो मैं उसको सिंपली कॉपी पेस्ट करता हूं, गूगल पे डालता हूं, ट्रांसलेट में मेरे को पता लग जाता है व्हाट इज द मीनिंग और मैं उसका रिप्लाई भी जो है वो उसी वे से कर देता हूं। तो दैट इज कॉल्ड मशीन ट्रांसलेशन। तो देखो कितना इजी कर रहा है कम्युनिकेशन को, कि अगर आपको यही काम पहले इंटरप्रेटर करते थे, मतलब आप किसी दूसरे देश में जा रहे हो, वहां की आपको लैंग्वेज नहीं आती, तो ऑब्वियसली आपको इंटरप्रेटर को हायर करना पड़ेगा, उसको पैसे देने पड़ेंगे, आप बोलोगे वो पहले आपको समझेगा और हो सकता है वो 100% वैलिड आंसर ना दे पाए क्योंकि ह्यूमन बीइंग है और ह्यूमन बीइंग जो है वहां पे गलतियों के चांसेस है। लेकिन अगर ये चीज आप मशीन को दे दोगे तो मशीन एज इट इज जो है वो करेगा, अगर इसको आप प्रॉपर ट्रेनिंग, प्रॉपर एक्सपीरियंस के साथ करोगे। तो जितना आप इसको प्रॉपर करते जाओगे तो उतना ही आंसर जो है आपका वैलिड आता जाएगा। देन चैटबॉट्स, ईबे के चैटबॉट्स में होता क्या है कि जल्दी क्या होता है, जब हम चैट करते हैं तो एक तरफ ह्यूमन बीइंग है, दूसरी तरफ रिप्लाई करने के लिए भी ह्यूमन बीइंग होता है। लेकिन आजकल जो है स्मार्ट चैटबॉट्स आ रहे हैं जिसमें आप कोई क्वेश्चन पूछते हो तो सामने से ह्यूमन बीइंग नहीं होता, वहां पे मशीन होती है। मशीन अपने पूरे डेटाबेस में से, पूरी नॉलेज बेस में से आपको रिप्लाई करती है और वैलिड रिप्लाई करने की कोशिश करती है, दैट इज अ चैटबॉट। तो ये सबसे जो मेन एग्जांपल है, इसके अलावा बहुत सारे एग्जांपल है। एडवर्टाइजमेंट मैचिंग है कि कैसे हम एडवर्टाइजमेंट्स हिस्ट्री के बेसिस पे हमें रिकमेंडेशंस आती हैं। स्पेल चेक्स जो है आजकल बहुत सारे सॉफ्टवेयर आ रहे हैं स्पेल चेक्स के ऊपर कि कैसे स्पेलिंग चेक करते हैं पूरे के पूरे टेक्स्ट स्पीच में से। तो ये जो सारे बहुत सारे एग्जांपल जो आपको मिल जाएंगे, लेकिन मैं यहां पे एक सिंपल से एग्जांपल से आपको समझाना चाहता हूं कि एनएलपी होता क्या है। तो यहां पे सबसे पहले हम इनपुट दे रहे हैं और उस इनपुट को ऑटोमेटिक स्पीच रिकॉग्नाइजेशन, ऑटोमेटिक स्पीच रिकॉग्नाइजेशन जो है वो सॉफ्टवेयर क्या करता है, उसको स्पीच को उठाएगा और उसको टेक्स्ट में कन्वर्ट करके एनएलयू क्या है, नेचुरल लैंग्वेज अंडरस्टैंडिंग या नेचुरल लैंग्वेज इंटरप्रेटर। वही बात जैसे कि मैं यहां पे बोल रहा हूं तो आप ये सारी चीज सुन रहे हो, जैसे ये सारी चीज आप सुन रहे हो साथ ही साथ जो है आपका क्या है, इंटरप्रेटर काम कर रहा है, यहां पे अंडरस्टैंडिंग जो है वो काम कर रही है। मतलब आप सारे वर्ड्स को कलेक्ट कर रहे हो, उसको अंडरस्टैंड करने की कोशिश कर रहे हो, फिर आप क्या करते हो, नेचुरल लैंग्वेज जनरेशन, फिर आप उसके बेसिस पे आप डिसीजन लेते हो कि क्या रिप्लाई करना है। तो मतलब रिप्लाई भी आपका वैलिड होना चाहिए। और इसको मैं होता क्या एनएलयू एनएलजी में क्या होता है, इसको मैं पूरी डिटेल में समझाऊंगा। एक सिंपल से डेमो के साथ मैं आपको समझाना चाहता हूं यहां पे कि ये एक्चुअल में काम कैसे करना है। सिंपल मैं गूगल असिस्टेंट का यहां पे यूज कर रहा हूं। हे गूगल,
Hi, what can I do for you?
how are you?
I'm doing great. Thanks for asking. What can I help you with?
What is natural language processing?
Here's a summary from Wikipedia. Natural language processing is a subfield of computer science, information engineering, and artificial intelligence concerned with the interactions between computers and human languages.
सो देखो हमने यहाँ पे किया क्या, बहुत ही सिंपल से वर्ड्स, मतलब मैंने यहाँ पे कुछ वर्ड्स को बोला, कुछ सेंटेंसेस को बोला और गूगल असिस्टेंट ने सबसे पहले उसको क्या किया, रिकॉग्नाइज किया, मतलब मेरे वर्ड्स को रिकॉग्नाइज किया ऑटोमेटिकली। फिर उसके बाद अंडरस्टैंडिंग मतलब उन सारे वर्ड्स को कलेक्ट किया, उनका मतलब समझने की कोशिश की कि मैं एक्चुअल में कहना क्या चाहता हूं, मतलब व्हाट आई वांट टू से, व्हाट इज माय इंटेंशन, और उस इंटेंशन के बेसिस पे ही जो मेरी इंटेंशंस है उसी के बेसिस पे वो रिप्लाई करने की कोशिश करेगा। तो यहाँ पे मैं एक सिंपल एग्जांपल से आपको बताना चाहता हूं। नेचुरल लैंग्वेज अंडरस्टैंडिंग होता क्या है, व्हाट डू द यूजर से, मींस व्हाट इज देयर इंटेंशन, व्हाट इज द मीनिंग, मतलब वो क्या कहना चाहते हैं, उनकी इंटेंशन क्या है। और ये एक्चुअल में बड़ा ही चैलेंजिंग काम है। ये एक्चुअल में इसको हम एआई, आर्टिफिशियल इंटेलिजेंस हार्ड प्रॉब्लम, एआई हार्ड प्रॉब्लम्स में से आता है, क्योंकि ये दिखने में आसान लग रहा है कि ठीक है जो मैं बोल रहा हूं वो उसको टोकनाइज कर रहा है, उसको अंडरस्टैंड कर रहा है। नहीं, यहां पे बहुत सारे चैलेंजेस हैं और सबसे बड़ा चैलेंज क्या है? एम्बिग्यूटी। मतलब जो आप समझ रहे हो, जो लैंग्वेज आप यूज कर रहे हो, लेट्स से मैं इंग्लिश लैंग्वेज यूज कर रहा हूं, तो यहां पे बहुत सारे वर्ड्स हैं, बहुत सारे टाइप्स की एम्बिग्यूटी आती है, तो उस एम्बिग्यूटी को कैसे हटाना है, ये सबसे बड़ा चैलेंज है यहां पे मशीन के लिए। तो एनएलयू सॉफ्टवेयर जो है वो बहुत ही बड़ा चैलेंजेस है यहां पे। सबसे पहले अगर हम बात करें लेक्सिकल एम्बिग्यूटी, देन सिंटैक्टिक एम्बिग्यूटी, सिमेंटिक, प्रैग्मेटिक। ये सिंपल सा वही काम है जैसे हम कंपाइलर के अंदर बात करते हैं कि हम एक सी का प्रोग्राम डालते हैं और उसमें कंपाइलर में क्या करते हैं, हम सबसे पहले यही तो काम करते हैं, लेक्सिकल एनालिसिस करता है, फिर वो सिंटैक्टिक चेक करता है, सिमेंटिक एरर चेक करता है। तो यहां पे लेक्सिकल एम्बिग्यूटी का मतलब क्या है? लेक्सिकल का मतलब क्या है? जो वर्ड्स हम बोल रहे हैं, जैसे मैंने बोला हाउ आर यू, तो हाउ आर यू ये एक्चुअल में टोकनाइज हो जाता है। टोकनाइज का मतलब है ये अलग-अलग वर्ड्स में कन्वर्ट हो जाता है। अब जब ये अलग-अलग वर्ड्स में कन्वर्ट होगा तो ये भी पॉसिबल है कि एक वर्ड के मल्टीपल मतलब हो। जैसे कि एक सिंपल एग्जांपल से मैं बताता हूं, द टैंक वाज फुल ऑफ वाटर, मतलब जो टैंक है वो पानी से भरा हुआ था। अब यहां पे पानी से भरा हुआ था तो समझ आई, लेकिन टैंक यहां पे क्या है? पानी वाला टैंक जो हम घरों में यूज करते हैं या आर्मी का टैंक। तो यहां पे ये जो टैंक है ये मल्टीपल मीनिंग्स जो है, यहां पे मल्टीपल मीनिंग्स को रिप्रेजेंट कर रहा है। तो यहां पे मेरा जो रिप्लाई है वो उसी के अकॉर्डिंग होना चाहिए, जो मेरा कॉन्टेक्स्ट, जो मेरा क्वेश्चन है, क्वेश्चन के कॉन्टेक्स्ट के बेसिस पे ही मेरा आंसर होना चाहिए। तो ये बहुत बड़ा यहां पे एम्बिग्यूटी का चैलेंज है, किसके लिए? एनएलयू के लिए। नेक्स्ट अगर हम बात करें सिंटैक्टिक एम्बिग्यूटी, सिंटैक्टिक एम्बिग्यूटी एक्चुअली में बात करते हैं यहां पे स्ट्रक्चर की। जो स्ट्रक्चर है हमारे सेंटेंस का, जब हम पास करते हैं किसी भी सेंटेंस को, तो हमारा जो सेंटेंस का स्ट्रक्चर है वो एक्चुअल में पूरा वैलिड होना चाहिए। अगर उसमें कोई प्रॉब्लम हुई तो स्ट्रक्चर में ऑब्वियसली कहीं ना कहीं प्रॉब्लम आएगी। जैसे ओल्ड मैन एंड वुमेन वर टेकन टू द सेफ प्लेस, मतलब बुजुर्ग पुरुषों और औरतों को सेफ प्लेस पे ले जाया गया। तो प्लेस मतलब बुजुर्ग पुरुषों और औरतों को सेफ प्लेस पे ले जाया गया। तो यहां पे जो मेरा ओल्ड मैन एंड वुमेन, मतलब बुजुर्ग औरतें और बुजुर्ग, मतलब क्या है यहां पे? ओल्ड मैन, ओल्ड वुमेन। क्या यहां पे दोनों को ओल्ड मान रहा है? मतलब जो मैन है वो भी ओल्ड है, वुमेन है वो भी ओल्ड है, या फिर वुमेन ओल्ड है लेकिन मैन ओल्ड नहीं है? मतलब यहां पे कहीं ना कहीं एम्बिग्यूटी है, दैट इज ओल्ड मैन एंड वुमेन। तो ह्यूमन बीइंग के लिए इस चीज को मतलब अंडरस्टैंड करना थोड़ा इजी रहता है, क्योंकि हम कहीं ना कहीं इंट्यूशन को, थोड़ा बहुत सेंटीमेंट्स को भी यूज करते हैं, थोड़ा बहुत हम कहीं ना कहीं इंट्यूशन को यूज करते हैं, जिससे हमें लगेगा कि ओल्ड मैन एंड वुमेन मतलब ये ओल्ड वुमेन की ही बात कर रहा है। लेकिन मशीन के लिए इस चीज का यूज करना, इस तरीके से दिमाग लगाना, मशीन के अंदर तो कोई दिमाग है नहीं, यही तो हम चाहते हैं कि आर्टिफिशियली वो इंटेलिजेंट बने। तो यहां पे ह्यूमन बीइंग के पॉइंट ऑफ व्यू से तो वैलिड है, लेकिन अगर आप मशीन को दे रहे हो तो आपको प्रॉपर देना पड़ेगा, दैट इज ओल्ड मैन एंड ओल्ड वुमेन वर टेकन टू द सेफ प्लेस। अगर आप इसको पूरा एम्बिग्यूटी से रिमूव करना चाहते हो। देन हमारे पास आती है सिमेंटिक। सिमेंटिक के अंदर हम बात करते हैं मीनिंग के रिलेटेड, मतलब मीनिंग क्या है उसका। जैसे कि द कार हिट द पोल व्हाइल इट वाज मूविंग, तो यहां पे एक्चुअल में क्या है? कार हिट द पोल व्हाइल इट वाज मूविंग। तो यहां पे मीनिंग के अंदर देखो कहीं ना कहीं आपको एम्बिग्यूटी मिल रही है कि मूव क्या कर रहा है, कार मूव कर रही थी या पोल मूव कर रहा है। तो यहां पे कहीं ना कहीं एम्बिग्यूटी है मीनिंग के अंदर। अगर मैं हिंदी में बोलूं, चलती कार ने बच्ची को टक्कर मारी, या आप इसको ऐसे भी कह सकते हो कि कार ने बच्ची को टक्कर मारी जब वो चल रही थी। तो यहां पे क्या चल रही थी? कार चल रही थी या बच्ची चल रही थी? तो यहां पे कहीं ना कहीं मीनिंग से रिलेटेड जो है वो एम्बिग्यूटी है। तो इस एम्बिग्यूटी को रिमूव करना सबसे बड़ा चैलेंज है। तो उसके लिए बहुत सारे यहां पे हम लेमनाइजेशन का यूज करते हैं, यहां पे हम स्टेमिंग का यूज करते हैं, यहां पे हम नेम एंटिटी रिलेशन, जैसे हम हिंदी की अगर बात करें तो हिंदी में हम इन सारे वर्ड्स को कन्वर्ट करेंगे कि इसमें नाउन क्या है, संज्ञा क्या है, एडवर्ब क्या है, विशेषण क्या है, यहां पे वर्ब क्या है, क्रिया क्या है, इन सारों को हमने डिवाइड करना पड़ेगा, इन सारों को हमने टोकनाइज करके पासिंग करके फिर हमें पता लगेगा कि एक्चुअल में यहां पे नाउन क्या है, एडवर्ब क्या है, वर्ब क्या है। उसके अंदर भी आपके जैसे संज्ञा के अंदर हमारे पास जातिवाचक, व्यक्तिवाचक, भाववाचक, मतलब इनको आपको फर्दर डिवाइड करना पड़ेगा, तब जाके आपको एक एक्चुअल में आइडिया मिलेगा कि एक्चुअल में इसका कॉन्टेक्स्ट क्या है, मतलब ये क्या कहना चाहता है, मीनिंग क्या है। देन
Messas who live business.
प्रैग्मेटिक। प्रैग्मेटिक जो है अगेन ये भी बहुत ही चैलेंजिंग सी एम्बिग्यूटी है। इसमें प्रैग्मेटिक में होता क्या है कि कंटेक्स्ट ऑफ द फ्रेज गिव्स द मल्टीपल इंटरप्रिटेशन, मतलब आपने एक वर्ड लिखा, एक सेंटेंस लिखा, उसके मल्टीपल इंटरप्रिटेशंस आ रहे हैं। जैसे द पुलिस आर कमिंग, मतलब पुलिस आ रही है, किसके लिए आ रही है? मेरे लिए आ रही है, आपके लिए आ रही है, या इस एरिया में आ रही है, किस लिए आ रही है? एक्चुअली में यहाँ पे मल्टीपल मीनिंग्स बन रहे हैं। तो ह्यूमन बीइंग के हिसाब से तो हम कहीं ना कहीं थोड़ा, जैसे मैंने पहले बोला, हम कहीं ना कहीं सेंटीमेंट्स को लगाएंगे, यहाँ पे हम थोड़ा बहुत अपना इंट्यूशंस को लगाएंगे, अपने पास्ट एक्सपीरियंस को लगा लेंगे कि पुलिस आ रही है, हो सकता है इस एरिया में आ रही हो। लेकिन अगर आप यही लैंग्वेज मशीन को दे रहे हो तो मशीन इसको कैसे इंटरप्रेट करेगा? मेरे लिए आ रही है, आपके लिए आ रही है, इस एरिया में आ रही है, घूमने आ रही है, क्या करने आ रही है? तो इस चीज को अगर आपको एम्बिग्यूटी से रिमूव करना है तो एनएलयू का जो सॉफ्टवेयर है वो बहुत ही इंटेलिजेंट होना चाहिए। तो ये एक्चुअल में सबसे मेन चैलेंजेस आते हैं एनएलयू के अंदर। देन हमारे पास एनएलयू के बाद नेक्स्ट फेज आता है एनएलजी, दैट इज नेचुरल लैंग्वेज जनरेशन। जब हमारे पास सारा अंडरस्टैंडिंग हो गई, जैसे हमारे माइंड ने सारी अंडरस्टैंडिंग कर ली, अब हमें क्या करना है? अब हमें रिप्लाई करना है। तो रिप्लाई जो है, व्हाट शुड वी से टू द यूजर, तो यहां पे एनएलजी के ऊपर हम काम करते हैं कि एक्चुअल में अब यूजर को क्या रिप्लाई करना है, क्योंकि जो भी रिप्लाई करना है इट शुड बी इंटेलिजेंट एंड कन्वर्सेशनल, मतलब जो आप रिप्लाई कर रहे हो वो इंटेलिजेंट होना चाहिए और कन्वर्सेशनल होना चाहिए। मतलब जो यूजर ने पूछा है वही आपके उसी के बेसिस पे आपका रिप्लाई होना चाहिए। जैसे कि यूजर ने पूछा कि गूगल असिस्टेंट से कि गूगल असिस्टेंट टेल मी द नियर बाय प्लेसेस टू ईट, और आप रिप्लाई कर रहे हो उसको, या मशीन रिप्लाई कर रही है कि नियर बाय प्लेसेस फॉर क्लॉथ शॉपिंग। तो यहां पे कपड़ों की शॉपिंग के बारे में मेरे को आंसर आ रहा है, लेकिन मैंने पूछा था खाने से रिलेटेड, तो ऑब्वियसली ये मेरा आंसर जो है वो इररिलेवेंट है। तो इस चीज को सबसे पहले हटाता है कौन? नेचुरल लैंग्वेज जनरेशन। तो नेचुरल लैंग्वेज जनरेशन में हम करते हैं टेक्स्ट एंड सेंटेंस प्लानिंग, मतलब हमारे पास पूरा कॉर्पस है। कॉर्पस क्या होता है? एक्चुअल में पूरा का पूरा डेटाबेस, मतलब पूरा का पूरा हमारा नॉलेज बेस है। उस नॉलेज बेस में से हम पहले टेक्स्ट को प्लान करते हैं, वर्ड्स को प्लान करते हैं कि क्या वर्ड्स होने चाहिए, फिर उसके बेसिस पे हम सेंटेंस को प्लान करते हैं। सेंटेंस को प्लान करने के बाद हम यहां पे स्ट्रक्चर का मतलब है हम यहां पे स्ट्रक्चर डेटा के ऊपर डील करते हैं। और स्ट्रक्चर डेटा का मतलब है, अगर मैं सिंपल एग्जांपल से बोलूं तो अगर गूगल असिस्टेंट पे या आप ऑनलाइन अगर चेक करो कि व्हाट शुड बी द वेदर इन द नेक्स्ट वीक, तो नेक्स्ट वीक में मतलब क्या वेदर होगा, कैसा वेदर होगा, तो आपको पूरा एक स्ट्रक्चर वे से रिप्लाई आएगा, मतलब एक पूरा बॉक्स बना होगा जिसमें प्रॉपर वे से मेंशन होगा कि मंडे को ये, ट्यूसडे को ये, वेडनेसडे को ये, और पूरा एक उसकी समरी भी होगी जिससे आपको पूरा एनालाइज हो जाएगा तो वो एक स्ट्रक्चर डेटा में आपको रिप्लाई करता है, और ये रिप्लाई इस तरीके से होना चाहिए कि यूजर ने जो क्वेश्चन पूछा है उसी के बेसिस पे रेलेवेंट जो है वो आंसर होना चाहिए। तो ये एक्चुअल में पूरा का पूरा जो है सिस्टम ये नेचुरल लैंग्वेज प्रोसेसिंग के अंदर आता है, दैट इज स्पीच रिकॉग्नाइजेशन, या जो भी आप टेक्स्ट दे रहे हो उस टेक्स्ट को रिकॉग्नाइज करके ये जो दो मेन फैक्टर्स है दैट इज NLU एंड NLG। सो दिस इज ऑल अबाउट द बेसिक इंट्रोडक्शन ऑफ नेचुरल लैंग्वेज प्रोसेसिंग। थैंक यू। डियर स्टूडेंट्स, वेलकम टू गेट्स मेशर्स। आज की वीडियो में एक्सप्लेन करने जा रहा हूं आर्टिफिशियल न्यूरल नेटवर्क, इसका आर्किटेक्चर किस तरीके से वर्क करता है। विद रियल लाइफ एग्जांपल इस पूरी चीज को एक्सप्लेन करूंगा ताकि आप बिल्कुल बेसिक से बिल्कुल स्क्रैच से सारी चीजों को सीखो और फिर एडवांस लेवल तक पहुंचो। एडवांस लेवल की अगर मैं बात करूं, आज के टाइम हम लोग बात करते हैं LLMs की। LLMs मतलब लार्ज लैंग्वेज मॉडल्स। जैसे आपने सुना होगा लामा के बारे में, अभी मेटा ने लॉन्च किया लामा 3, या फिर आपने चैट जीपीटी के बारे में तो ऑब्वियसली सुना ही होगा, बर्ड के बारे में सुना होगा। ये सारे जो प्रोजेक्ट्स हैं ये बहुत बड़े लेवल के प्रोजेक्ट्स हैं, जहां पे इन सारी जो हम बात करते हैं ना ये आर्टिफिशियल न्यूरल नेटवर्क की, मतलब ये है बिल्कुल बेसिक ब्लॉक। आप मान के चलो ये है नर्सरी क्लास, और हम लोग आज बात कर रहे हैं PhD की। लेकिन डायरेक्ट PhD थोड़ी ना हुई है, स्टार्ट तो हमने कहां से किया, नर्सरी से किया, फिर फर्स्ट क्लास, सेकंड, इस तरीके से हम लोग मूव किए। तो इसलिए पहले आपको ये सारी चीजें बेसिक से पढ़नी पड़ेंगी, क्योंकि ये सारे जो LLMs मॉडल्स की हम लोग बात करते हैं आज के टाइम पे, या फिर फ्यूचर में भी जो AI की बात करते हैं, उनका स्टार्ट जो है वो यहीं से हुआ है। तो इसीलिए आपको सारी कंपोनेंट्स को बिल्कुल बेसिक से पढ़ना पड़ेगा। सारी चीजों को अगर आप एग्जांपल के साथ रिलेट करके पढ़ोगे तब आपको बहुत अच्छे से समझ आएगी। तो देखो,
I can guarantee
आर्टिफिशियल न्यूरल नेटवर्क ANN, इसका जो बेसिकली पर्पस क्या है कि हमारा जो ह्यूमन ब्रेन है वो किस तरीके से वर्क करता है उसको मिमिक करने की कोशिश की है, मतलब उसकी एक तरह से कॉपी बनाने की कोशिश की है कि जिस तरीके से हमारा ब्रेन चीजों को कैलकुलेट करता है, चीजों को समझता है और फिर आउटपुट जनरेट करता है, उसी तरीके से हम लोग एक आर्टिफिशियल न्यूरल नेटवर्क बनाना चाहते हैं ताकि हम लोग इनपुट दें और हमें एक रेलेवेंट आउटपुट निकल के आए। अब जो ANN है, जो आर्टिफिशियल न्यूरल नेटवर्क है, इसके अंदर कौन कौन से बेसिक कंपोनेंट्स आते हैं? तो यहां पे सबसे पहले आते हैं न्यूरॉन्स, लेयर्स, मल्टीपल लेयर्स आती हैं, कनेक्शंस, एक्टिवेशन फंक्शन। अब सबसे जो बेसिक यहाँ पे यूनिट है वो क्या है? न्यूरॉन, या जिसको हम नोड्स भी बोलते हैं। तो ये जो न्यूरॉन्स है इसको आप बेसिकली ऐसे समझ सकते हो कि ये डेटा स्टोरेज की, मतलब एक तरह से इसमें क्या है, कुछ वैल्यूज, कुछ डेटा जो है वो स्टोर किया हुआ है। जैसे मैंने यहाँ पे 0.2 कुछ भी एक वैल्यू, कुछ भी एक नंबर जो है वो स्टोर किया हुआ है, तो आप एक तरह से न्यूरॉन को इस तरीके से कंसीडर कर
Hello.
Don't be afraid of neural networks, they're not scary, even when a neural network says boo. Hello, I'm Josh Starmer, host of the StatQuest with Josh Starmer YouTube channel, and I'm here to say that neural networks are not scary. Now, the term neural network may sound really fancy and complicated, but all a neural network does is fit a squiggle or a bent shape to data. For example, if you've got a data set like this, then a neural network can fit a squiggle to that data. Bam! And if you've got a fancier data set like this, then a neural network can fit a bent shape to that data. Double bam! And if you've got a crazy complicated data set like this, well, a neural network can still fit a squiggle or a bent shape to that data. Triple bam! Hooray!
Neural networks. Fast. Hello, I'm Josh Starmer, and welcome to StatQuest. Today we're going to talk about neural networks part 1, inside the black box. Neural networks, one of the most popular algorithms in machine learning, cover a broad range of concepts and techniques. However, people call them a black box because it can be hard to understand what they're doing. The goal of this series is to take a peek into the black box by breaking down each concept and technique into its components and walking through how they fit together step by step. In this first part, we will learn about what neural networks do and how they do it. In part 2, we'll talk about how neural networks are fit to data with backpropagation. Then we will talk about variations on the simple neural network presented in this part, including deep learning.
In the ₹9 workshop.
Note: crazy awesome news! I have a new way to think about neural networks that will help beginners and seasoned experts alike gain a deep and fancy mathematical notation to represent neural networks. In contrast, I'm going to label every little thing on the neural network to make it easy to keep track of the details. And the math will be as simple as possible while still being true to the algorithm. These differences will help you develop a deep understanding of what neural networks actually do. So, with that said, let's imagine we tested a drug that was designed to treat an illness, and we gave the drug to 3 different groups of people with 3 different dosages: low, medium, and high. The low dosages were not effective, so we set them to 0 on this graph. In contrast, the medium dosages were effective, so we set them to 1. And the high dosages were not effective, so those are set to 0. Now that we have this data, we would like to use it to predict whether or not a future dosage will be effective. However, we can't just fit a straight line to the data to make predictions, because no matter how we rotate the straight line, it can only accurately predict 2 of the 3 dosages. The good news is that a neural network can fit a squiggle to the data. The green squiggle is close to 0 for low dosages, close to 1 for medium dosages, and close to 0 for high dosages. And even if we have a really complicated dataset like this, a neural network can fit a squiggle to it. In this stat quest, we're going to use this super simple dataset and show how this neural network creates this green squiggle. But first, let's just talk about what a neural network is. A neural network consists of nodes and connections between the nodes.
3 simple things.
Note: the numbers along each connection represent parameter values that were estimated when this neural network was fit to the data. For now, just know that these parameter estimates are analogous to the slope and intercept values that we solve for when we fit a straight line to data. Likewise, a neural network starts out with unknown parameter values that are estimated when we fit the neural network to a dataset using a method called backpropagation. And we will talk about how backpropagation estimates these parameters in part 2 in this series. But for now, just assume that we've already fit this neural network to this specific dataset. And that means we have already estimated these parameters. Also, you may have noticed that some of the nodes have curved lines inside of them. These bent or curved lines are the building blocks for fitting a squiggle to data. The goal of this stat quest is to show you how these identical curves can be reshaped by the parameter values and then added together to line or elevation functions.
Imagine
and a spider web of connections between each layer. Build a neural network hidden layer. Dose 14 raised to the let's exit and values from 0 within the scale 2.25. So we multiply 2.25 by negative 1.3 and get negative 2 point coordinates on the 4 point. Remember, just like before, estimates on that squiggle. We 0 squiggle is double.
I don't know. I think I will end. Bye.